Being in the Pacific Northwest where it rains a lot, I've decided to build a rain catchment system instead of drilling a well. Since I've never done this before, I've decided to start small. My plan for now is to build a small roof and attach it to the top of the shipping container. I was lucky enough to be given two 55-gallon plastic drums by a neighbour. According to most popular equations, you should be able to collect half a gallon of water per square foot of roof for every inch of rainfall. If this is true, an 8-foot by 16-foot roof should be able to fill both my barrels with less than 2 inches of rain. For the time being, this will mostly be used just for irrigation, but with the right filtration system, it could serve a lot more uses in the future. So the first step in my plan is to build a stable base for the drums. I want them to be raised up enough that I can fill a bucket or a watering can, but the main purpose of the system is to run a supply line down to the greenhouse, which is about 30 feet below this location. At 1 psi for every 2.3 feet of elevation, that should enable me to achieve about 13 psi at the greenhouse. I'm hoping this will be enough to run an irrigation system and water the garden. With a good strong bed of gravel, concrete blocks and some 2x6s, it was time to add some cross bracing. As usual, my preference is to use scrap wood for this kind of project, and if you've watched any of my other building videos, you'll know I have a stack of dunnage wood I got from a local lumber yard. Dunnage wood being mostly 2x4s of lengths under 4 feet, it's basically perfect for a project like this. I wanted to have 2 cross braces per barrel to give them stability, so I needed to cut 8 2x4s, just under 24 inches long. Here I'm using nails, which I don't often do, and if I'd thought ahead about how much I was going to have to adjust the system as I figured out how to connect the barrels together, I would definitely have used screws. These barrels are a little under 24 inches wide, and right here you see me making my first mistake, thinking I'll have room to expand the system to 4 barrels in this 8-foot width. Ultimately I realised that there's not enough room between the barrels to connect them. But like I said before, my plan is to start small, and I can always make adjustments as I expand the system later. Predictably enough, it started to pour with rain at this point, so I went inside to do the indoor portion of the project. So just a quick rundown of the plumbing supplies I bought. I did some research and found this drum funnel. They're used in an industrial setting to pour chemicals into drums without spilling them. There should be enough capacity in the funnel that even if it fills with leaves and debris, the water can accumulate and then drain through the sieve. Hopefully this mesh will be fine enough to stop mosquitoes. For connecting the drums together, I got this high-pressure 1-inch water pipe called Hydromax. To connect that to the 1-inch bulkhead and 1-inch shut-off valves, I'm using this. It's a 1-inch NPT threaded adapter with a 1-inch barbed hosepipe connector. To secure it, I'm using a stainless steel hose clamp. I've seen a lot of people use rigid PVC to connect rain barrels together, but my instinct is that I'm going to need to move things around, and things may shift, and having a flexible pipe just seems like a better idea. On the barrels themselves, I'm going to be using this 1-inch bulkhead with a silicone seal. Each bulkhead hole will be fitted with a 1-inch shut-off valve, to which I can connect either the 1-inch high-pressure hose or using a 1-inch to 3/4-inch hosepipe adapter to connect a regular garden hose. Because rainwater is inherently dirty, I decided to get an inline filter that I can place anywhere in the hosepipe chain. There's a pretty fine mesh and should be able to filter out most debris. It's definitely not fine enough to make it into drinking water, but it should be good enough not to clog up any irrigation or drip lines, and might be clean enough to shower with. Just a side note, this is exactly the kind of thing that breaks in a sudden freeze. Winterizing is definitely something I need to get better at. So the next thing I need to do is drill a hole big enough to get this bulkhead attached to the drum, which I'm going to do with this hole saw. After a lot of back and forth, I've decided to connect the barrels at the bottom so they'll fill simultaneously up to the same level. I'm drilling holes at about 6 inches above the base of the barrel, which is about 5 inches on the inside. This is a little excessive for the amount of water you want to have left in the barrel to collect the sediment, but it's also the flattest portion of the barrel, which is where I wanted to connect the bulkheads. With that slightly nerve-wracking first hole drilled, it's now time to figure out where the other hole's going to go. I want to offset the holes a little so the attachments don't stick out into the walkway where they might get bumped into by people or animals. So I ended up spreading them apart about 120 degrees. After reading lots of conflicting reports about what kind of sealants to use on these types of plastic drums, I decided to try an experiment with RubberFlex. It's a flexible rubber sealant that's potable water safe, and if the claims on the packaging are to be believed, it should do a pretty good job with this. I gave the insides and outsides of the hole a pretty good clean, and applied a generous amount of RubberFlex to the seal. The bulkhead is attached with a reverse thread. I didn't have a big enough wrench for the fitting, so I improvised with a clamp. After attaching the shut-off fitting with just plumber's tape, I decided it didn't feel quite tight enough, so I decided to experiment with pipe thread sealant. This putty-like substance appears to fill all the available gaps, and gave me a lot more confidence about the final seal. With the clockwise thread of the fitting and the counterclockwise thread of the bulkhead, I was able to achieve what feels like a very tight seal. But only time will tell. And on the inside of the barrel, the RubberFlex appears to be doing its job nicely. With the temperature in the shipping container around 40 degrees Fahrenheit, I figured it would be smart to let the RubberFlex cure for at least a week before connecting the rest of the system and testing it with water, which you'll see in the next video. Feel free to subscribe if you want to be notified when that goes live, or search my channel for part 2 of the rain catchment system build. If you have any questions or comments, feel free to leave those in the comment section below. Either way, thanks for watching.